This is the temperature experiment. Which temperature conditions favor the activity of catechol oxidase? In introduction to this experiment, again we use a potato extract as our enzyme. It's important to note that the enzyme is in a brown liquid, and the product of the reaction that the enzyme catalyzes is seen in a brown product, which is benzoquinone. We use water baths for the enzymes first to change only the enzyme. Then we continue the experiment in the water bath so the enzymes cannot fold back into their normal shape when returned to optimal conditions. In the previous chapters, we learned that enzymes, based on their primary structure, may have the ability to denature and then renature when they are put back in their normal conditions. So to ensure that this does not happen, we kept the enzyme in the water bath for the whole experiment. The procedure was to label 6 test tubes, put 1 ml of catechol oxidase, or the potato extract, in each tube. We used water baths for 10 minutes to reach the specified temperatures, which were 0, 20, 40, 60, 80, and 100. This provided a broad range of various temperatures for us to carry the experiment out. And then after 10 minutes we added 1 ml of catechol to each tube, and we kept these tubes in the water bath for 10 more minutes. When we put the catechol in there, oxygen was already present, as oxygen is in our air, and oxygen is required for this reaction. And then we recorded our observations using the scale you provided on the wiki page. So here are our results. Tube 1, you can see, is a brownish color. Tube 2, a little darker than Tube 1. Tube 3, darker than Tube 2. Tube 4, lighter than Tube 1. And tubes 5 and 6 are clear. So based on this, we made our conclusions. So tube 1, which was at 0 degrees, we used ice to cool the tube down, and this had a color change on the scale of 0 to 3 of 2. The enzyme is functioning, but not producing the most benzoquinone. So this is not the optimal temperature for the enzyme. At 20 degrees Celsius, which was room temperature, in this case we didn't need to cool or heat the enzyme, but we did leave it at room temperature for 10 minutes. The enzyme is close to optimal performance. We ranked this color change as 2.5. At 40 degrees Celsius, we had a color change of around 3, and the enzyme is very close to optimal performance here. 3 was the highest color change we saw in this experiment. At 60 degrees Celsius, there was a color change about 1.5. The enzyme has not become unusable, however, it is not performing optimally. The limited benzoquinone, the brown product in this reaction, is produced. At 80 and 100 degrees Celsius, the color changes are 0. The enzymes at these extremely hot temperatures have denatured and are not producing any benzoquinone because the reaction cannot take place while the enzymes are denatured. Our conclusion is that the shades of brown are darkest on tubes 2 and 3, and it is the absolute darkest on tube 3. The optimal temperature should be between 20 and 40 degrees Celsius, and this is going to be closer to 40 degrees Celsius because the tube 3 was the darkest brown. And no benzoquinone is produced in tubes 5 and 6 because the enzyme was denatured due to the water bath. Conclusion to the whole general experiment. What did we learn about catechol oxidase and its optimal conditions? Our conclusion. The enzyme catechol oxidase has a set of optimal conditions at which it performs, or it takes place in the reactions most efficiently. The temperature is around 35 degrees Celsius, give or take a few degrees, and a pH of 6. Now these two conclusions, these two statements, are backed up by our experiments, in which we showed that our test tubes that we had created, the enzyme worked most efficiently at the pH of 6 and around the temperature of 40 degrees Celsius. And we also concluded that enzymes denature when the environment is significantly changed. Hence, at extreme temperatures and pH, extreme temperatures such as 80 and 100 degrees Celsius, and the pHs of 2 or 12, or even catechol oxidase does not function at all. Once the enzyme, in this case catechol oxidase, has denatured, no reaction is going to take place. And as we talked about before, catechol oxidase is needed to get over the initial investment. So the reaction will not take place at extreme temperatures or pH. And some enzymes can renature when the environment is turned to normal. In this case, in this experiment, we did not test for this because we left the test tubes in the water bath after even adding the catechol. Thanks for watching.